All right, I think I'll get started because we've waited for quite some time now. Sorry about the delay, everyone. So, hello again, and I'm super glad that I'm getting to present about WebAssembly and its associated landscape today to several of y'all, and I see some familiar faces in the crowd as well. I hope you're having a fantastic day so far, and I hope that if you're joining in from the other side of the globe and you're just starting off with your day, you have an amazing day ahead. So some ground rules, because I feel like that will help both of us if during the course of this presentation or session or whatever else you want to call it. The agenda is going to be fairly straightforward. It's about the WebAssembly landscape, how we, got started with WebAssembly, why we got started with WebAssembly, the associated ecosystem, the way ahead, and some community and learning resources. And any questions or any, queries that y'all might have, I'd request y'all to reserve them for the end of the session because I would it breaks my flow, and then I ramble a lot. I don't want to waste more of your time here. So that's just the basic ground rule, nothing else, nothing fancy. So that being said, I still haven't introduced myself. So I am Divya Mohan, and I am a technical writer at SUSE. So a lot of my day job is documenting cloud native technologies. But before I actually became a technical writer, I have a breadth of expertise in systems engineering, web technologies, and in people management as well. So I also love doing community stuff like speaking at events, which is also why you're seeing me here. And on the internet, and specifically on social media for tech, I am on Twitter, and you can find me at the handle that's there on the screen. And most of my work is in the open source space, like I mentioned before. So you can find me on the GitHub handle here. And if you're interested in learning more about me, because I didn't want to fill an entire slide with details, you can scan the QR code and go through the whole process of understanding what all I have done in the past 9+ years of my IT career. But coming back to today's topic, which is WebAssembly and its associated landscape and the ecosystem, like every hero and a villain, it has its own origin story. So, what is WebAssembly's origin story and when did it start? The origins of WebAssembly can sort of be traced back to the origins of the web because let's face it, it's there in the name itself, right? So this was like 30-ish years ago, right around the time I was born. And a lot of people might here in the audience might not even know that this is the first page of the internet. So the web page that you can see here is largely static. In fact, there are not a lot of dynamic elements to this web page. And it was started off like the whole concept of the internet or the world or the web as it was conceptualized was started with an aim to enable documentation sharing among academics. The first web server, as we know it, ran on Next Computer at CERN, and this was the homepage that was there. Now, with the evolution of the internet, and as we know it today, the web is way more dynamic, way more interactive, and you can do a bunch of things. And that doesn't it is not limited to just file sharing. You have video content, you have animated content, you have a lot of pictures and stuff being shared and uploaded. Hell, you can actually even you know um, do an entire workload online and stuff like that. So, I mean, we've come very, very far from where we started. And a lot of it began because of JavaScript as a programming language and plugins. Now, plugins, we all know that they are no longer, with us as technologies because of various reasons, which we shall cover in the next few slides. But JavaScript is very much there as a programming language for the front end in various flavors today. If you just have a look at the number of flavors of JavaScript in existence, it's probably more than the number of fingers on your hand. So, what exactly um, what exactly catapulted JavaScript to the to becoming the trifecta in terms of uh, the web front end framework, and why are we looking at WebAssembly as an option, and how did WebAssembly come as a natural progression from JavaScript? So when we talk about JavaScript, it's just a programming language, and it was conceptualized with an aim to be the programming language of the web. So along with HTML and CSS, it was there to provide that level of interactivity. And when people realized that, the web was growing and the internet was sort of becoming a thing, they wanted to bring in more and more applications to the front end, not to the front end really, to the web, because more visibility means more customers. More customers is more money. No brainer, but yeah. So people wanted to bring in more web apps, but the challenge with the web app, bringing the web apps to the web, is that a lot of the applications that were written earlier on were in stronger type languages like C++, Java, stuff like that. So bringing those to the front end sort of resulted in a lot of performance inconsistencies, and we shall see like why there was a need for an alternative. But essentially what was required was that in order to bring anything to the web, it needed to go through JavaScript. So basically JavaScript was and is also right now sort of a gatekeeper in terms that everything needs to be compiled to JavaScript. And because of the inconsistencies when it came to higher intensive workloads, it basically started, throwing up performance issues. Essentially, what happened is a programming language was, because of its ubiquity, turned into a compilation target. And when that happened, obviously, if something's used for a purpose that it was not designed for, it's going to throw up flaws here and there. Maybe not consistently, but there will be flaws noticed. And that's what happened with JavaScript. But what about plugins? Because I spoke about plugins, and if you look at the browser ecosystem right now, you don't see a lot of them around. So plugins were, sort of introduced in the early 2000s, if I'm not wrong, in the early days of the internet, to as an alternative to JavaScript. And what they also sort of brought along were easy ways to introduce malware into your systems as well. So they were a massive security nightmare. But that was not one, that was just one aspect of it. The other thing that sort of led to the decline of usage of plugins is the fact that there were compatibility issues observed across devices, which sort of meant that when you were talking about plugins used for a specific ecosystem, say Windows, the same plugins would probably not work when it came to another ecosystem. And given that non-standardization, people started searching for alternatives. And the first of them was not asm.js. There were many others as a precedent, but asm.js is the closest to the WebAssembly specification. And what is it exactly? It is a subset of, it is a strongly typed subset of JavaScript. I would really love to take a moment here and appreciate Bailey for the amazing slide and the presentation that she gave at Cloud Native Wasm Day, which sort of named asm.js as the greatest hack ever. The reason being, when you had to actually compile, when you had to actually bring a lot of C++ code to the front end, it was a challenge before the, you know, creation, or the, I wouldn't say invention, but the creation of the mscripten toolchain. But with the mscripten toolchain, a lot of the C++ and C code that you probably wrote as a developer for apps could be brought to the front end, and compiled to the asm.js specification. Um, Now, this was, like I said, the closest that we got to WebAssembly as a specification. But again, there were problems, right? Because why did we move away from asm.js? Um, the reason being, asm.js was sort of a disjointed effort. Uh, there were efforts made by different browsers and different companies in this space, and all of them were working towards the same goal, but in a very disjointed manner. So with the asm.js specification, we also had the native client and the portable native client implementation from Google, and eventually they were working towards the same goal, but it was not a standardized effort. So what was decided in 2015, as we shall see in the next couple of slides, is that all the major browsers would sort of come together and work towards a standardized specification for an alternative, and that is where WebAssembly as a specification was announced first. This is the progression that I spoke of a couple of slides earlier, wherein WebAssembly, how we reach WebAssembly from the JavaScript ecosystem, and there are a lot of elements on this slide. But what I'd like you to particularly focus on is the fact that a lot of the core tech that is there at the bottom of the slide is what propelled the development of the other elements that I spoke about, like mscript and portable native client, asm.js. Because as you know today, WebAssembly is very commonly associated with Rust, and I don't think a lot of people, can differentiate between the two. So a lot of the developments in the core tech also sort of were there that propelled the ecosystem towards an alternative. Now, like I said before, it was 2015 when the first announcement for WebAssembly was made and demoed, based on an initial implementation of the feature set of asm.js. Um, there wasn't a lot of you know progress being made according to the public in the next couple of years. But 2017 was when the actual MVP was announced. That is version 1 of the WebAssembly specification. So we've seen the journey of how we went from the initial page, initial front page of the web with absolutely no dynamic content, to the part where we have the WebAssembly specification. And I still haven't talked about what it is. So that's in the next slide. Um, WebAssembly is essentially a framework which defines a portable language agnostic compilation target. Now, when I say this, you'll be like, okay, so what does it actually mean? Is it like, written in a specific language? So it is written, I wouldn't say it is written unless you were actually planning to write compiler level stuff, or you're looking to optimize your compiler for WebAssembly. But if you're planning to, it is written in assembly level programming language, in a language that is similar to assembly level programming language, and there is an associated textual and a binary format for the specification. And the reason why it is called WebAssembly is that it was designed keeping in mind the web initially, but now, as we all know, it's extended beyond the web and gone to server side and other environments. So right now I've said that it can be used in other environments, but where is it being used currently? I could probably be just hoodwinking y'all and saying that, okay, it's used in XYZ area. But as you shall see in the in the ecosystem slides that will come after this, uh, WebAssembly can literally be used anywhere at this point. It's utilized on the web, obviously, because the name is WebAssembly. But there are also WebAssembly, you know, uh, implementations for desktop apps. There is, stuff going on in the cloud native world, wherein you can, where there is support for WebAssembly in containerization. It's also, there's also obviously work going on for WebAssembly to be implemented on the edge, because as an industry, as we all know, we are moving towards the edge. We are moving to bring compute closer to data. So edge implementation is a no-brainer, and then it can obviously be used on various architectures on account of its portability. So desktop, edge, and mobile are sort of the three different places where it can be used. Now, you remember these two bad guys, right? That I spoke about, Flash and Silverlight. They were plugins and they were used for a really short period of time in the early 2000s. And I said that they were used to bring in that level of interactivity and dynamism and stuff like that. But guess what? Now you are able to provide a Flash emulation via the Ruffle project, and it's actually being used for powering, our pandemic favorite apps of Zoom, Google Meet, and Prime Video. So there you have it. You actually have proper WebAssembly implementation in stuff you use every day. So that being said, we've spoken a bit about what WebAssembly is, and we've seen a glimpse of where it's used currently. So let's go ahead and see the various ecosystem components, and particularly focusing on WASI and the component model. So just to preface how important the WebAssembly specification and the WASI specification is, Solomon Hykes, who is the co-founder of Docker, um, went out and said that, if these were existing back in 2008, which was when Docker was conceptualized, we wouldn't have needed to actually create Docker at all, because a standardized system interface was the actual missing link, which is what Docker worked towards. And then we had the whole containerization revolution and stuff like that. So what is Wasm? So like I said, it's an acronym for the system interface for WebAssembly. So why do we need a system interface is the very first question. It doesn't the system define one? So the answer is no, it doesn't. And therefore, a different specification that sort of focused on on this, Wasm code communicating with the system was required. So we have the WebAssembly system interface. Now, the proposals are many. There are various proposals under the WASI specification, but the ones that are currently generally available are, proposals dealing with, like these are the features that are currently available. So you have input output access, file system access, but unfortunately limited networking capabilities. It was a drawback that was there. I wouldn't say it's a drawback, but it's also a feature. So it's not a bug, it's a feature. But with Wasm and WASI, the main thing was that there was limited networking capabilities, which was sort of addressed with the WebAssembly gateway interface specification. Um, and that being said, I know that there have been a lot of acronyms thrown at y'all. Y'all don't need to worry. There's a lot of reference that I've included in the slides, and they will be shared. This will be shared on my GitHub. So please don't worry about a lot of acronyms if you don't get it right away. Now that we've spoken about the specifications, for anyone who's a software engineer, or has studied computer engineering, or has been in the industry for quite some time, a component model is something you all must be familiar with, which basically describes the system or software in terms of different components and their interlinking dependencies and hierarchies and stuff like that. So we have one, and we're currently developing one for Wasm as well, and that is with an end goal of making it language agnostic. It is language agnostic. WebAssembly is currently has always strived to be language agnostic, but the approach for software development with the component model is aimed towards a more agnostic approach. And the major feature of this is to ensure that like with programs currently being broken down, a monolith program being broken down into microservices, the end goal is to have that with WebAssembly as well. So an interlinking of or layering of WebAssembly modules one about the other is what is the end goal of component model. So the WebAssembly specification, which is the absolute bare bone, will be at the base, and things like WASI and other specifications would sort of actually be interconnected to have that whole feature set that we want at the end of it. And the component model does not endorse, I wouldn't say endorse, that's not the right word, but the component model does not really expect that the entire feature set be used, but as and when whatever is required, that is sort of pluggable, and you take it away from and whatever you don't need is sort of not actually used. And for ensuring the security of all of this, as with WebAssembly modules themselves, nothing is shared in WebAssembly. That's one major thing that basically contributes to a lot of the security that that the specification is famous for. So you cannot explicitly access memory in WebAssembly. The host memory is not something that is explicitly accessible to the WebAssembly module. You are given a specific set of memory locations, and you're able to access only that. So with respect to the component model, the sort of vision is the same. And now we come to the different ecosystem components, because we've talked a lot about the various um, uh, you know not, I wouldn't say frameworks, but different specifications associated with Wasm. But we also need to know what are the available runtimes, because do we know any of them? Do we actually you know are we aware of all of these, is something that you know people might think of. So this is not an exhaustive list. There are a ton of runtimes out there, open source and proprietary. And if you are at if you have some free time once this presentation is done, there's an entire listing on a GitHub repo with appropriate linking. So there's a lot of variety on the plate if basis the capabilities that you want to leverage. So that's a list of runtimes that is there on the screen right now. With respect to platforms, you're spoiled for choice as well, because not only do you have um, major market players like Fermion, Suborbital, Wasm Cloud, and the rest are also up and coming organizations in the space, and they are more focused on different aspects. It's not that every platform that I've listed here focuses on the same thing. So Suborbital is aiming to better the developer experience, and Fermion is aiming to bring WebAssembly closer to the cloud. Mycelial is an edge platform for WebAssembly. So there are variations, and basis the different use cases that you probably would love to leverage it for. These are up and coming market players in this space. And when we talk about bringing more languages to the web, it is obviously essential that you have something in between to actually compile your code to a WebAssembly format, because the WebAssembly format is obviously not going to be automatically generated when you write your code. So these are some of the compilers that are out there, and it's just a matter of time. So, till the ecosystem actually develops and becomes a full-fledged behemoth. Because every single week there's a new development coming up in this space, and it's definitely a hard task for people to keep in touch with all of that. um Now, when I spoke about compilers, I also mentioned that we're trying to bring more languages to the web, and via this whole specification. So there have been extremely new languages that have been created for just WebAssembly. One of them is TypeScript, which is like a sister of JavaScript. And then there's Grain. And then in the compile languages section you'll find a lot of familiar stuff like C++, C, Rust, stuff like that. And in the scripting languages section, which are more you know uh, which have been which are more recent in nature, there's C, Ruby, and C Python. So there's a support for a lot of languages, and the ecosystem as a whole is trying to be more welcoming and trying to power more development in this space, because the aim is to have a language agnostic ecosystem altogether, and of course to bring more accessibility to developers in terms of the language they code in. So we've talked a lot about the actual state of the ecosystem with respect to the different you know components and different runtimes and different languages. But we're right now at a juncture where cloud native is extremely an integral part of our development process. um, Partly because I don't think there are a lot of organizations or individuals out there who've not heard Kubernetes or Docker. So uh, even if you've not heard of them, even if you've not actually used them, you've definitely heard of them in some form or the other. And cloud native is here to stay, because the essential goal that we are moving towards is um, the further decoupling of app development from the actual process of you know managing the infrastructure that it is deployed on. Which is why you can see which is why you can see on the screen that as we move from the left to the right, there is a more declarative approach that is being adopted in terms of app development. And we are at the stage right now wherein we are able to containerize and not worry a lot about um, the actual, operating system that we run upon. And when I actually started off in IT, we were pretty much, I think, closer to the VM side of things. And I'm sure people who started before me can vouch for the fact that, tightly coupled architectures and tightly coupled, applications were 10,000 times more difficult to maintain. So, right. So I went a little bit off track there, but with this, progression, where are we right now when it comes to, Wasm and cloud native? So we have a bunch of projects, and I have not included all of them for, the sake of, saving space here, but Warden is one of them which I work with personally, and we've reached 1.0.0 just last week, so shout out there. But Crustlet is another, is the Rust implementation of the Kubernetes, and basically OPA, Envoy, and Istio, and other cloud native projects are also slowly introducing support for WebAssembly, because they identify the fact that, WebAssembly offers them the portability that a lot of languages that these um, projects are right now written in don't offer them. And not only that, there's the feature of security as well. So these are some of them. This list is not exhaustive at this point. And like I said, every single week there is a new technology tool or market player coming up. So it's pretty difficult to keep track at this point. And for those who still aren't convinced that, we are literally, growing at the pace of uh, I don't know what, but at this point we are growing pretty soon, pretty fast, sorry. These are like a bunch of things where WebAssembly is currently in use as of today. So whether it's your IoT devices, whether it's your web devices, whether it's, blockchain, whether it's gaming, WebAssembly is everywhere, and it's pretty much here to stay. So that being said, let's quickly look at the future for this ecosystem, because it's not done developing, right? So we'd like to have a quick glimpse. And this is, of course, based on what I know. It's not a prediction of any sorts, but this is where I see the ecosystem heading. So maybe that this will eventually become the default compilation target in the future. Currently, it is JavaScript. It's very much JavaScript definitely rules the roost, but with the way the ecosystem is developing and the pace at which it is developing, it feels that probably it could have the possibility of becoming a default compilation target. And it has all things in place, right? It's standardized, it's fast, it's portable, it's secure. So it definitely has a lot of things going for it. And a lot of what I actually shared before in terms of you know the run times and the various applications and the various platforms, a lot of it is moving towards the fact that you just bring your code, we'll take care of the rest. So that is not how it is currently. So um, we are essentially moving towards a plug and play application development model. And with the evolution of the component model, like I said, one of its visions was to have language agnostic, language neutral Wasm application development, and for standardizing software development process as a whole. And And with that, I think we have covered the gist of where we have covered the gist of the ecosystem and the origin story. So let's look at the community and learning resources. This is a listing, so I won't take too much of time. So um, these were specific. So the learning resources that I share on the next slide are specific to my learning journey. I come from a systems engineering background. I'm not a development. I was not into software development, and my programming language knowledge was okay at best. So that next slide will probably be much more useful for people who are beginners in the space, absolute beginners. And this specific slide is a bunch of places where community where the Wasm community is there. So Wasm.builders is an excellent blogging platform wherein there's a plethora of content around you know uh, WebAssembly, not just the WebAssembly specification, but different implementations of WebAssembly. Like people speak about their learning journeys, people speak about their implementations or new stuff that they've come up with. And then there's also these um, non-profit organizations that are there that help provide a vendor agnostic space for the WebAssembly ecosystem to grow. One of them is the Bytecode Alliance. Then there's the CNCF. There's the Confidential Computing Consortium. There's the W3C community group. So these are a bunch of places where you can find WebAssembly folks. And with respect to learning resources, I um, I will always start off with Lynn Clark's blog, although I've listed the weekly newsletter here first. We'll always start off with Lynn Clark's blog because it's kind of like a holy grail at this point in time when it comes to WebAssembly. And Radu's blog as well. He's one of the co-founders of Fermion. It's very insightful. The specification docs, that is not it's not the docs, the specification website in itself is very insightful, albeit a little jargony. Piece of documentation to go through. Although once you get the grip of it, you do understand a lot of what they're trying to say. And the developer docs from Mozilla are absolutely great for anyone starting off with a base of JavaScript. Like, I knew JavaScript in a very basic manner, but the developer docs for Mozilla really sort of helped me even with my very basic knowledge. And last but not the least, the first item on here is the WebAssembly weekly newsletter, which helps me keep track of the weekly ongoings in the WebAssembly ecosystem. So yeah, that's pretty much it from my side. And thank you to whoever tuned in. And I think I'll take questions right now and stop sharing at this point. So yeah. So right, anyone's having any questions? I'd be I'm just gonna scroll through. Let me see the question. All right. So I think the first question that I see here is WebAssembly a potential alternative for Docker by Federico? So at this point in time, no, because Docker is I wouldn't say Docker. So had it been, like I said, back in 2008, if that was the case, that Docker was not there and we were speaking of WebAssembly and WASI then it would have been. But right now, with a lot of our stuff going towards containerization and WebAssembly running within containers themselves. I don't think it's an alternative for Docker, but they work in amalgamation is more like it. So I don't think it's an alternative for Docker, but it will work in tandem with Docker and the other existing technologies that we have. So I hope that answered question. Yes, and Janet, yes, I am going to provide the link. I'm actually sorry I did not do that earlier. I will be providing a copy. I have not yet uploaded it, so I'll be doing that in a bit. I do not upload it till the end of the after the end of till the end of the event. So just let me do that, and it should be up in like half an hour after the event gets done. So this is the place where you can find the talk at after like half an hour. So yeah, any other questions that you might have, I'm happy to take them. Okay. Hi, Chris. So how do you get started? So it actually depends where you are on your learning journey. And I got started by actually going through those blogs that I mentioned. So the first thing that I did was read through those blogs and read through the specification to understand basically what the whole specification was all about. So that is essential to me as a person to understand it. And I don't, I'm not a programmer, so going from scratch helps me. But if you're a programmer and if you're more interested in diving right in, a lot of the projects, open source projects that I mentioned, they are all ready to accept contributors, but that's a separate plug. With respect to learning, how you can learn the bare bones of WebAssembly is to actually try out one of those projects. Like you can sort of take one of the projects and try having take one of the projects like compiler projects and consider converting your program into a WebAssembly format, and you'll probably understand what actually that helps with. And once you go from there, you will once you actually see the output, once you figure out what that helps you in a wider scope, there will be specific implementation use cases that you need to look at. You are not going to just write a code and compile it to WebAssembly and leave it at that, right? So there will be different use cases that you want to try out. A lot of fun stuff had happened in the cloud native Wasm day, wherein people actually ran WebAssembly on Raspberry Pis and stuff like that. So if that's something of your interest, that is a good way to start. But I would definitely recommend to start off with the specification itself, because that's how I did. And I come from a non-programming background, so it was easier for me to learn it from scratch.